As you can see, in this my target word is A, B, C, D, E, F. That is the case, I can use these words. So obviously we will do the exact same as what we did here. We will try to check, okay, so I have to start from here. I have to make the entire word target. So I know that I can choose A, B, D, E, F or A, B, C as a starting. So I can choose either A, B, D, E, F or A, B, C as a starting. Okay, I choose A, B, D, E, F, A, B, C. I have both the options. As I have both the options, I will try for both the possibilities. And when you try for both the possibilities, you know that you can try for simple recursion. And then you also know that these possibilities can turn up to actually have overlapping subproblems. If not, then go and watch this video. So we also know that we have to apply DP. Now in that case, after ABC is applied, then your string remains this. Again, for this, I simply can see I can either start with DE, sorry, only D and or DEF. So I will start with D or DEF. In that, nothing is remaining empty here, but here I have EF remaining. So can I make a EF? Yeah, I can make an EF. So I made my EF. As you can simply see, if you have to find the minimum cost, you will take, okay, to make this, I incurred a cost of 100. Again, I have taken everything from the cost array. Here, the cost required was 1, but to make the rest part of the substring, I will again take the minimum cost. Here, if I would have attached directly, it would have incurred me a cost of 10. So, if I would have done ABC and DEF, then it would have given me a cost of 1 plus 10, which is 11. But I know, instead, I would have taken only D and only EF. Then only D would have given me cost of 1 and only EF a cost of 5. So in total, the cost would have been 1 plus 5, which is the minimum cost, and that is my answer. So you could see very easily that I will have to apply my DP, but if I apply my DP, then how will I write the same thing? I will simply say that I have this specific string. If I have this specific string at a specific starting index, I will go and try for all the substrings. I will go and try for all the substrings, and I will go and check for all those substrings. Are they present in my words array or not? If they are present in my words array, then okay, put them as it is. Try to decrement your DP value, because your DP value will say at that point what is the minimum cost. So how the problem will look like. You will start from a specific index. You will have some specific word array. You will have to go and try for all specific substrings starting from that index I, and then check that substring is inside my words array or not. So basically your DP of I will store, again, if you go back to the words problem, this word break, it stored is it possible, true or false. But here I will store if it is possible or not. If possible, then what's the minimum cost? So I have to show both the things. Now to show both the things, there's a very standard technique that you can by default initialize your DP array to int max. So if int max is there, which means it is not possible. If it is not int max, it is possible. And then if it is not int max, you will store the minimum value, minimum DP value. That's what you want in the answer also. So you will store minimum. You just minimize your value. This DP of I will store the minimum cost to make the string up till the index I, starting from the index 0, which means from here up till this point, what is the minimum cost you needed? Again, Aryan, but you told like it should store up till index I. Yeah, in word break also, like we did up till index I, but I'm just showing you one more variation which makes your code a bit more easier, that you can store, okay, were you able to make this part, and this will store the next upcoming part. Okay, from I and onwards you can minimize your string length. Again, this is just variation. You can also store your DP of I contain the value from 0 to I itself, or in this case you will see the code which I will show, it will store that was it possible to make your string from 0 to index I minus 1, and I will start off from index I and look forward. Now what I will do when I say look forward, I will look and go and look for all the substrings starting from index I, and when I say substrings, I mean, okay, I, then I plus 1, then I plus 2, up till let's say index n. So basically it is I to j as one substring. It should be there, and then if it is there, I know I can simply for j plus 1, as I told you, because I am storing answer for this. So my DP of I will say, okay, this portion was possible. So if I was able to find my string from I to j, then I will update my j plus 1. Okay, just saying that up till j it was possible. Then start looking from j plus 1 up till the future. and thus update your DP of j plus 1 with the help of your DP of I. Again, repeating, it is exact same as what we discussed here also. Now, coming on how the code will look like, simply you will try for all the starting indexes I. You will try for all the after indexes j, which means j starting after I, and then you will grab a substring from I to j. You will check if that substring is inside my words array or not. If it is, then you will update your DP of j plus 1. Okay, and again, when I say update, you have to minimize your DP value because DP value stores cost and you have to minimize the cost. And when I say cost, I mean the cost of this substring from I to j and the cost of DP of I itself. Thus, you are just simply minimizing your cost. Now, what is the complexity of this if you used only DP? If you only used DP, then because of these two for loops, it is evident that it will take O of n square time. But then the next part is generating a substring, which will take, let's say, O of n time. But even after generating substring, you have to find that substring, or you have to find that string from I to j inside your words array. And you can easily see that your words array, like it can have n elements, and then you have to search for that character. So basically, if I just look at these constraints, okay, word length is n, so I have n words. Each word is of target length is also n, so each word is also of a size n. Each word is also of size n, and I have such n words. So roughly you can see I will have n square characters in total. It might feel like, although you can see a constraint here also, but it might feel like I have total of n square characters. If I have n square characters, so basically I will have to go and search for this string in all the, basically, because see, n square characters, which means I have n string each having a length of n. So comparing one string, if I compare two strings each of length n, it will take O of n time, and I have n such strings, so it will take O of n square time. So this might feel like it will take O of n square time just to compare the string with the words string. Now, although you will see very easily that it is bounded by O of n, it is bounded by 5 into 1e4, which means these total number of characters are itself at max n. At max n. So for sure, you will only be needing to compare n characters. But the catch here is that here I told you have to compare only n characters. But it's very easily possible that one string is the same way as I told, that one string is a, then other string is AA, then AAA, then AA. So it seems like roughly O of n square will also go here if the strings are same, because see, if your actual string from I to j was a, then you will go and find a here, then you will go and find AA here, then you will go and find AAA here. So it is simply increasing. So roughly it will also go to up till O of n square, even if you compare only character by character. Then okay, the two things are there. One thing is that my for loop, other thing is comparing my string. I have some string which I will make for sure from I to j. I just have to check, is that string inside my words array or not. That also we had already seen. The optimization is via a try, because try is something when you have to find a string in some search space, find a string and find its existence in a string in some search space, we can take use of a try, because try helps us to remove the redundant searches. Because how a try is built is, again, just go and watch this video itself. It will have everything. But just to give a quick recap, how a try is there is, I have a string A, B, C, D. I have a string, let's say B, A, C. And I have a string A. So let's say I have strings in my word array as A, A, and then I have, let's say, A, B, C, D. I have, let's say, A, B, I have B, A, and I have B, A, C. So basically how a try will look like is, it will have these as the end nodes, then AB, this as the end node, then again BA, this as the end node, and BAC as the end node, and let's say make this also ABCD, and this also as the end node. When I say end node, I mean my try, if it has to go and search for a substring, let's say AAA, it will go and look for A, then another A, then another A. Yeah, it was the end node, which means my AAA as a substring was present. And while I was searching my try, I also would have easily found out if A only would have been there, if AA would have been there, and if AAA would also have been there. So it's very easy to search in our try. Again, references word break video. So we realize that searching for a string of length n exactly in my words array, worst to worst case will take O of n time, because I will have to go and search for every character of my target word. So that will take O of n time in worst case if I will use a trie for my searching. But now again the bottleneck is O of n square. If you go and look back, a very basic, when we optimize our normal brute force approaches, the thing which we apply, same technique we can apply here. Aryan, what do you mean by normal brute force optimization? If you remembered, whenever I ask you generate substrings for a specific string, what do? You can put a I loop which will go, and then you will try for all the j loops starting after I. Then j will be here, then j will be here, then j will be here, and then j will be here, and then your j will be here. So you try for all the possible j. If I say your j is here, then you will take a substring. You will, let's write s dot sub str I comma j minus I plus 1. Write this, and then you have generated a substring. So what you did? You did 3 steps. Firstly, you applied a for loop, I for loop, j for loop, and then generate a substring. So it will take O of n cube time. But we have seen the brute force optimization by saying that you don't have to build the substring here itself. You can make your string s array here itself, and while you go on to a specific j index, just push back and say s dot word of, let's say I, let's say word is just a word, simple word, which means this is simple a word w. Let's say this is simple w. So simply do a w of j. So you will simply keep on adding w of j in your s. So in the very beginning, when your j is here, your s will be a. When your j is here, then only b is added. So s will be ab. Then j is here, then only c is added. So s will be abc. So while putting your for loops itself, you are generating the substring. So same way here, I don't need to specifically go and do all this stuff. While I'm generating my substring, while generating itself, I will be going and checking in my trie. Thus, I will not be needing to have this extra check, which means this n square loop will help me generate the substring, and then I would have separately went on and checked that specific substring in my trie. That will not be required. How I will do it? While generating my substring itself, I will also be checking in my trie. That is how I will use this specific strategy. So ultimately we realized it will be O of n square. But still O of n square will still not pass, because n is 5 into 1e4, which will be 25 into 1e8, which is again like in Leetcode will not pass. So are we missing something? Because we have used DP, we have used trie, still we are actually missing out. So are we missing something? That you can simply check by simply saying that why do you think it will go? Because see what this n square loop will say. This n square loop simply says for a specific index I, you are going and trying to check for all these substrings starting from that index I. Now, as we told that while we generate the substring, in the very beginning it is A, next time it will be AA, next time it will be AA. So we told that we can optimize that when I am at A, I will go and check A in my trie. Then I increased my length, so I'll go and check another A in my trie after my previous pointer, so as to not begin from the very start. Then I will go and check for the next A in my trie, then the next A in my trie, then the next A in my trie. So it feels right that this A can go up to the length of n. So technically I might be searching for this A again and again in my actually words array, which will form my trie. But the catch here is the constraints, because if you feel like that you will have to go and check for a, and this can be a length of n, you are wrong, because you are searching for a specific substring of your target element inside your words array. Your words array itself should contain a, and so on and so forth, Then, if this is the case, which means if I write this down, okay, a, a 4 times, a 5 times, up till how many times a can come? I'm just asking how many times a can come consecutively in my words array. if this is a pattern, if you are saying this is a pattern in which you have A, you also have AA, you also have AAA in your words array, I'm asking simple question, how many times A can come here? So if that's a question, and it's a simple answer that it is bounded by n. If you go and look back, it is, if I go and show you, it is bounded by 5 into 25, which is simply the length of the target element, target array itself. If it is bounded by n, if this length is bounded by n, so if you keep on repeating this, which means A, then for sure a simple maths, simple AP, it will give you that k should be less than equal to 2 root n. If that is the case, which means k is less than equal to 2 root n, which means that this a at max, like this can be root n times. So you can keep on repeating this substring kind of fashion at max root n times, which means your j, this, where is this your j gone? Yeah, your j in worst case can at max go to root n time. And that is the best part, that you can simply make your j go to at max root n time. And thus your complexity will be, if I go back, your complexity will be not n into n, no, it will be n into root of 2n, root of 2n, and that's a complexity. Now again, you might say, Aryan, but you were telling about Aho-Corasick and all that stuff. Okay, no worries, I'll show you, but now you realize that this will easily work. So let's see the code. It's exactly same as what we discussed. We should be knowing the knowledge of try. Simply go and watch this one video. In that description of the video of word breakthrough, I have linked the try code also. So how the try code looks like? Firstly, when we say building a try, I will simply define my root node. As you can see, there's a root node. My try node structure looks like every node will have a specific character, will have a cost associated with it. Now, why that cost is needed? Because you should be knowing first thing. You should be knowing first thing that if I am building a specific try, let's say I build a try for this specific example. So if I just get the words array, which is this specific words array, if I build the try, it will look like A, B, C, D, E, and F, and then A, B, C. So these are the end elements. So they will have a cost associated with them. Their cost is 100. Here the cost is 1. Then I have a D. Then I have a D. Then I have a D, E, F. D will have a cost associated 1. F will have a cost associated 10. And then I have EF. Then I have EF. F will have a cost associated 5. So, and this is the root node where these are the children's. Sorry, these are the children's. So this is how my cost will tell me two things. If it's an end node or not. If it's an end node, then what is the cost associated with that end node? So this is how my try will look like. So I will by default initialize my cost to 1e5. This cost being 1e5 will tell me that this, if the cost is 1e5, then this is not the end node. If the cost is not 1e5, which means this specific node is the end node, and also this is the corresponding cost associated with it. And then there's simply taken 26 children because I have lowercase English alphabets. Now coming on back, the prime thing was just to add all these strings inside my try, which means building my try itself. So I just simply build my try. That's the exact same function which we always use. So simply going on to all the children's, if the child is not present, make a new child. If present, then go on to that child and assign the cost. Now, Aryan, you might say, Aryan, assignment should be just an assignment, right? You should have just assigned the incoming cost to your specific cost. No, my word array could also have repeating words. What I mean by that is that there could be a possibility that my DEF is repeated twice. But it could have been possible that currently when you actually began the DEF, it was 1, the cost is 1. Next time the DEF came, the cost became 10. So you should not override with the maximum cost. For every specific word, take the minimum cost. Thus, because it is never mentioned that the cost can never be repeating, so cost can be repeating. In that case, I can just simply take the minimum cost of whatsoever cost I am getting. Now, ultimately, when the try is built, now comes the chance of my DP. Let's see how my DP try run will look like. As I told you, my DP of I will store that up till a point I minus 1, if the string is built. If yes, then what is the minimum cost? So in the very beginning, I have empty string. So yeah, obviously it is built. So the cost here is 0. But for all the other, I put a cost as infinity, minimum cost as infinity. Infinity will tell me, is it even possible to build up till that point or not? Again, this infinity tells that up till so far, building a only string of length 1, which means up till index 0, is it possible or not? This infinity tells up till the index 1, was building my string possible or not? So everything in the very beginning is infinity. Cool. And remember, your answer will be stored at dp of n, because this will tell up till the index n minus 1, which is the entire string, was it possible to build that or not? If this thing, which means if your dp of n is still infinity, which means your answer is -1, which means it is not even possible. Cool. So what we will do? We know that at this point, the value is not infinity. At my dp of 0, value is not infinity, which means before this it was, we were able to make it, we were able to make a string. If we were able to make a string, now we can just simply try to put string here. Now I can easily see that I have to start searching for a, b, c, d, e, f. So when I was searching in my try, again, let's build the try. Let's build the try again. So with this root, I had a, b, c, d, e, f. So this was the my leaf nodes, and then I had a d, e, f. This was the leaf node, and then I have e, f, where this was the leaf node. If I remember correctly, it was 1, it was 10, it was 1, sorry, it was 100, it was 10, and it was 5. Now, as we know, as we are at the specific index a, we will simply go and try to, again, I am at the specific index I. I know I should be trying, because here it is 0, which means everything before it was possible to make. So I can simply go and try to place strings, substrings here itself at index 0. So I will try it. When I will say I will try it, I will go on to the next indexes. I'll go on to the next indexes. Okay. Next index j, next index j. So okay, at this index j, I will have only a. Search for a. Do I have a? Yeah, I have a. But still, even if I have a, this is not the end. This is not the end of the string. So I cannot update my like dp of 1 so far. No, this is not the end of the string. I can update my dp value only if I find the complete string. Okay. So far I have not found the complete string. Simply continue. So I will go and search for b next. But b next should be after the previous a only. Okay. Go and search for b next. Yeah, I found a b. It is still not end. Now I'll go and search for c. Okay, let's put the arrow. I'll go and search for c. Okay, I found a c. Yeah, c I found, and it is the end also. If that is the case, simply minimize your index. So which means up till this point I was able to make it. So I will simply minimize my dp of 3, and I put that dp of 3 was infinity previously. Now I minimize it to a value of 1. Okay, continue. Okay, I will try for e. Okay, try for d. After c it is d. Try for d, not, it is a not ending index. Try for e, not ending. Try for f. Oh, f is ended. Minimize it. So earlier it was infinity. Minimizing it, it became 100. So now, but you will say, Aryan, you were saying that it will go up till root n only. Your j loop here, your j loop went up till n. You were saying to us that it will go up till root n only. I told you, if you combine it again, as it went to n in this case, next time it will not even be possible to go to n again and again. In worst case, we saw the worst case possibility. The worst case possibility, how many times? Repeatedly, which means for all the i's, which means for all the i's here, how many times repeatedly I will be able to go on to my this specific try. That will be only when I have simple a again and again and again. That is the worst possibility. And for the worst possibility we saw, for all the indexes, it will be root n. But here, okay, you saw, okay, it is n for this first index. It will not be n for the next indexes. Not possible. And not even close to the actual worst case. So because the worst case we already saw. Okay, then we realize that we have minimized my dp value. Okay, go on to next index. Next index is this. But can I try even searching for bc like this? Is it a question for you? I will say no, because here if I just put it 0 and here it is infinity, You are trying to search for this. You are trying to search for this. Bro, this is saying I am as infinity, which means that it was not even possible. It was not even possible to make something up till index 0. It was not even possible. If that is the case, there is not even a point of searching or trying to search for, let's say, B, BC, BD, because you should not be placing something here if you know that something is already not built previously. So I will have to ignore it. Okay, I will ignore this. I'll move my I forward. Can I place my I? Can I start placing from C, C, D? No, obviously not, because there was no possibility that AB was made, and that was told by this infinity, telling there was no possibility that AB was made. So again, continue. I. Now I am at the specific index. This says value 1. What it means that minimum cost to make up till index 2 was a value 1, which means I have got up to index 2. I can start placing from 3 and 3 onwards. So I will start place D, DE, DEF like this. So okay, I will try for D. If I try for, oh, this is the end. If D is the end, simply minimize. If D is the end, simply minimize. So when I say minimize, I told you the formula which we saw, that if I am at a specific, if I go back and show you, where it is going, yeah, at a specific index, existing value, which is infinity in our case, or it can be any non-zero value also, the cost from a substring from that point, and then your DP of previous value from where you came right now. So if I go back down, what we realized that we came from this specific I, and we are saying that D was possible. So I have to update this index, which is DP of, again, if the J is here, so I have to update DP of J plus 1. If DP of J plus 1 should be, DP of J plus 1 should be minimum of DP of J plus 1. Right now it is infinity. And then the cost of that specific substring, which is 1 in this case, and from where you came, I came from DP of I itself, which was 1 also. So 1. So your DP of J plus 1 gave a cost of 2, and that's what you put here. Okay, then again go and try for J next. Okay, I'll go and try for J next. Here, oh, it is not end, so I should continue. Again J here, yeah, it is end. So I can simply optimize my answer, or basically minimize my DP of J plus 1. As you can see here, the J is 5. So J plus 1 will be 6. So simply minimizing your DP of 6 by saying, earlier the DP of 6 value was 100, but you have to minimize it. When I say minimize, you should put, okay, this specific thing, which means DEF, the cost was a 10. The cost was a 10, and the DP of I value is 1. So now the cost for you became 11. Minimize it with the value of existing, it was 100. So now your cost will become a 11. Okay, now again go on to the next I, because your J is done. Go on to your next I. As you go on to your next I, you will simply see, let me remove it, it's a bit slow, but yeah, as you go on next I, you will see, okay, it is simply, oh, I have a value 2, which means up till this point I was able to make it. So I will simply go and search for E, and then EF maybe. So I'll go and search for E. Is it end? No, it is not. Then F, yeah, it is end. Then minimize your answer. Same way saying, earlier the value was 11 of DP of 6, but then you will minimize by saying that current value will be a 5, and the existing value of DP of I was simply a 2. Thus, minimum value is 7, and thus your answer is 7. And as you want to get the entire string, thus your answer will be stored in DP of n itself. And this dry run was exactly same as what we wrote here also. That if I have DP of 0 as 0, then I went on to all the indexes. Then I check if it is int max, which means I was not even able to make from 0 to index I minus 1 as a string from my try. So I should not place anything starting from this index I onwards here itself. So I should continue. But if it is not non-zero, which means I was able to make previously from 0 to I minus 1, so I should be able to good. I should be good to place anything at this index I. Okay, I will make my current as a root, and I will start placing things. I will check the current element which I should be searching for in my try. I will try to search in my try. If I cannot find it, I should break it right now. If you will not break it, you will end up going to all the n and you will get a TLE. So this breaking is very important, so as that you achieve the complexity or you achieve the pruning part. Thus, okay, you if you're not able to find it, simply break. If yes, then simply go on to that specific child, which is that specific character, and then check if the cost is non-zero, which means it is an end node, which means it's a string, exact substring in my words array. If it is equal to 1 5, which means it is not exact string in my words array. Usually you use a flag variable, but that's redundant because cost will act as both the things for you. Now simply minimize by using your DP value, and ultimately your DP of n will be storing the answer. If it is infinity, then answer is -1, else the answer is minimum cost, which is DP of n. Complexity you saw will be O of n root n in worst case, and space will be O of n because of the trie. Now you will see that in many people, again, if you want to see the top down code, you can just go and check this submission of mine. Again, it gave a TLE because of many copies being handled. So again, complexity still technically should remain same, but because of Leetcode and its infrastructure, that gives you TLE. Again, if you in an interview, if you give this approach, it should technically be passed in an interview, I'm saying. But yeah, you can just go and learn for the bottom approach, which, because here everything I'm doing everything here itself. While in top down, I asked my DP to return a query for a specific index, what all end indexes are there, which is same way but still asking for a function, which gave okay TLE. But again, this is for just your reference. Last but not least, people are just shouting about Aho-Corasick. I'll give you a quick hint, or basically a quick recap of what Aho-Corasick means. Aho-Corasick simply means that it is a normal trie which is built. If I have strings, let's say BCA, so as you can see, BCA, I build a trie. Okay, I have CAAB, CAAB. Okay, I build a trie. Okay, and then AB. So that is normal trie which is built. Aho-Corasick simply says that build your false nodes, or basically break nodes also, or break edges also. What it simply try to say is that for a specific, let's say if I just go and ask BCA, so for a BCA, the suffix is, let's say, CA, right? Again, I'm talking about the proper suffix. The proper suffix is CA. Why not the entire suffix? Because entire suffix is BCA. That will be actually always be equal to BCA, which you have drawn right here. The proper suffix is CA. Now that proper suffix should be a prefix of some other node. As you can see, suffix, which is CA. If I just draw it right here, BCA, suffix portion is CA. So this CA, as you can see, is here. So this, as you can see, is pointing to a node which has a prefix in the trie itself. You might say, Aryan, I also had my suffix as a, but then why you did not put a edge here? Oh, you can see we also have a edge here also. We also have an edge here also to a, because that is also a suffix. So this is how Aho-Corasick works, that it goes and find for all the proper suffix, go and tell me that do I have a prefix in my trie only. For example, in this case, let's say if I do a BC, so C as a suffix, yeah, I have. So you can see I have an edge here. So this is how your Aho-Corasick works. Now, the use case for Aho-Corasick is finding the substrings when they're overlapping. What I mean by that is, if I would have changed the problem and I would have asked you that BCA, CAB, AB are your substrings and they can be overlapping and you are given the cost, then you have to go and find me the answer. Then one way, if you would have chosen the above approach, which we have learned so far, then you would have told that Aryan, BCA and AB are the two substrings which are not overlapping, thus the cost should be 101. But as I have allowed overlapping substrings, thus BCA and CAAB cost would have given me as 2. Thus the most optimal answer is 2. But this was, if you go and apply this approach, you will get 101, because that will consider only non-overlapping substrings, and that is why we were able to use simple trie and we were not bounded to use Aho-Corasick, because Aho-Corasick helps us in overlapping, because that you can easily see, right? When I have a BCA, I have a CAAB, The advantage of Aho-Corasick is finding this overlapping in very fast time and then going and pointing you to the next node from where you can start. That is the advantage what Aho-Corasick would have given you. In this case, it was not required and just an overkill. Cool. I hope you guys understood everything. Again, I was also confused. Like, I learned Aho-Corasick. Again, I didn't know about it. I just learned about it. I just saw the code. I just dry run the code. I just saw the complexity and everything. After that, I realized just an overkill. Cool. Bye. Take care. I hope you guys got it. For the folks who were wanting this video for so long, it has been just 2 days, but yeah, so long for me. Just smash like, baby. It helps motivate a lot because again, these kind of videos, weekly contest, no one watches. So I also have no motivation to make it. But if you like it, if you subscribe it, then it feels good to make it. Bye bye. Take care.